Welcome to today's lesson on the practice of civil engineering. Civil engineering isn't just about designing and building. It's about responsibility, relationships, and professionalism. Let's dive into what makes the practice of civil engineering a cornerstone of progress in society. First, let's talk about professional responsibility. Civil engineering begins with a profound responsibility. Engineers are tasked with studying, designing, and overseeing construction projects while ensuring safety, well-being, and comfort for the public. This includes protecting the environment and adapting to unforeseen challenges during the project's evolution. Civil engineers serve as faithful trustees for their clients, while also safeguarding the public interest. They must act ethically, communicate effectively, and build mutual trust with clients and project teams. By adhering to the highest professional standards, civil engineers uphold their obligations to the community, employers, and the environment. The relationship between a civil engineer and their client is critical to project success. Civil engineers must perform their services with reasonable skill, care, and diligence, ensuring clear communication and mutual understanding. They act as faithful agents for clients, providing professional judgment and balancing the interests of clients and third parties as required. Engineers also coordinate with other professionals, integrating their work into the overall project without being liable for their actions. When specialists or contractors are involved, the engineer ensures proper coordination, but is not responsible for their performance. Transparency is key, as civil engineers must disclose any conflicts of interest that may arise. The success of civil engineering services often depends on the client's cooperation. Clients have essential obligations to fulfill, including paying the civil engineer for services rendered as agreed upon in the contract, providing timely information and decisions required for the engineer to perform their services, cooperating with the engineer and avoiding interference with the services provided, ensuring access to project sites and facilities for inspection and supervision, arranging for additional services from other professionals when necessary and bearing the costs, routing all project-related instructions through the civil engineer when they are required to oversee the work of third parties or administer contracts, notifying the civil engineer in writing within 7 days of any changes that may alter the scope of services, along with details of these changes. In civil engineering projects, liability is linked to the duty of care. The civil engineer is only held accountable for damages if a breach of duty is proven, while the client is liable if they fail to meet their obligations. If any conflicts arise, arbitration is the preferred method for resolution. A neutral third-party arbitrator, agreed upon by both the civil engineer and the client, will assess any breaches of duty, ensuring a fair and professional process for resolving disputes. In civil engineering contracts, the civil engineer's liability is clearly outlined. The engineer is not responsible for errors in data, documents, plans, or specifications not prepared by them, nor for issues caused by the client, contractors, or other third parties. Even if the engineer makes recommendations, they do not guarantee the suitability or performance of other parties involved in the project. The engineer is not liable for the techniques, methods, or performance of contractors or third parties carrying out the work. If the engineer is found liable, damages are limited to reasonably foreseeable losses directly resulting from their breach. The maximum damages payable are capped at $300,000 or 10% of the engineer's portion of the project's damages, whichever is lesser. If third-party actions contributed to the loss, the engineer's liability will be proportional to their own breach. Suspension or termination of services. If conditions make it impossible for the engineer to perform, they must notify the client and request an extension. Either party can suspend or terminate the agreement with a 30-day written notice. The engineer can terminate if payment is overdue by 30 days or if services are suspended for over 6 months. In case of a dispute, the first step is conciliation between both parties. If unresolved, it will be taken to arbitration. Civil engineers and engineering firms offer a range of essential services for both public and private clients, ensuring projects are completed safely, efficiently, and within budget. Here's an overview of typical civil engineering services: design, consultations, and advice. Engineers provide design solutions based on client needs, offering expert advice to ensure projects meet safety, functionality, and regulatory standards. Feasibility studies. These studies assess the practicality of a project by evaluating factors like costs, site conditions, and environmental impact, helping decide whether a project is viable. Field investigations and engineering data collection. Engineers conduct surveys and collect on-site data on soil, terrain, and environmental conditions to make informed design decisions. Environmental assessments, impact statements, and engineering reports. Engineers evaluate how a project will impact the environment, covering aspects like air, water, noise, and ecosystems to ensure compliance with regulations. Preliminary and final designs, drawings, specifications, and construction bidding documents. Engineers create detailed designs, drawings, and construction documents to guide the building process and outline technical requirements. Assistance in securing construction bids and awarding contracts. Engineers help clients evaluate contractor bids, ensuring the best choice is made based on project requirements and budget. Construction, administration, and observation. Engineers oversee construction to ensure work follows design plans, meets safety standards, and stays within the project's schedule and budget. Arrangements for or performance of testing of materials and equipment. Engineers ensure materials and equipment meet specifications by arranging tests to verify performance and safety standards. Preparation of operation and maintenance manuals. Engineers create manuals for the ongoing operation and maintenance of infrastructure, helping ensure its long-term functionality. Appraisals and rate studies. Engineers conduct property appraisals and rate studies for utilities or services, ensuring fair and accurate pricing. Value engineering. Engineers assess project designs to identify cost-effective alternatives that do not compromise on safety, performance, or quality. Assessment of risks. Engineers identify potential risks, including environmental, structural, or financial, and work to mitigate them throughout the project. Structural remediation or rehabilitation. Engineers assess and repair aging or damaged structures, ensuring they meet safety standards and remain compliant with regulations. Project management and controls. Engineers manage projects to ensure they are completed on time, within budget, and according to quality standards. Teaching. Experienced engineers often teach, sharing knowledge through lectures, workshops, or training programs to guide future engineers. Within the practice of civil engineering, the PICE recognizes the initial 5 areas of specialization. A civil engineer who has demonstrated his knowledge, experience, education, and training in accordance with the requirements of the concerned specialty committee of the PCE is awarded a certificate of specialization by PICE. Those awarded with the certificates are considered qualified for positions in their respective areas of specialization. The PICE recognizes specializations in the fields of structural engineering, geotechnical engineering, water engineering, transportation engineering, and construction management and engineering. A civil engineer who is specialized in any area of civil engineering may be considered as a specialist in the appropriate field, as enumerated. The selection of a civil engineer is a critical decision in any engineering project. Their expertise directly affects design quality, financial investment, and project success. To ensure the best outcome, clients should prioritize experience, reputation, and skill over cost alone. A civil engineer should provide continuity of service from conception to completion, ensuring efficiency and long-term savings. Key selection factors include qualifications and experience, proven success in similar projects, interdisciplinary collaboration, ability to work well with design teams, lifecycle cost awareness, considering long-term project expenses, clear scope and expectations, well-defined agreements to prevent misunderstandings, following proper selection guidelines, like those from PICE and CIAP, ensure smooth project execution. Choose wisely your projects. Success depends on it. Foreign civil engineers can practice in the Philippines under specific conditions as stated in RA 8991. If their home country allows Filipino engineers the same rights under international agreements as consultants for foreign-funded projects when employed by Philippine or foreign private institutions. If they are former Filipino citizens with prior Philippine registration, however, their practice is not automatic. They must secure a license or special permit from the Professional Regulation Commission (PRC). Employers are also responsible for securing the required permits from PRC and DOLE RA 8981. Following the legal process ensures compliance and smooth project execution. Thank you for joining us today, and we look forward to seeing you in our next session. Until then, keep exploring, keep learning, and keep building. Thank you for joining us. And don't forget to follow and subscribe for more exciting content. Until next time, keep engineering.